So good evening students, this video is for you only. Okay, you have bound me to make this video, so I am making it. So what I am going to talk about in this video is inferential statistics. I know you know it, but then too I have to explain it. So what is this inferential statistics or inference statistics? Actually, it allows for inferences about population to be drawn from the sample data. So whatever we are doing analysis about the sample, we have to explain it, or we have to infer the result for the population. So that is inferential statistics. So we have two types of inferential statistics, I must say. One is parametric and the second one is non-parametric. We'll go deep in this after some time, but let me give you some examples of parametric and non-parametric. So the parametric tests are t-test, f-test, ANOVA, correlation, and also regression, multiple regression. Whereas in non-parametric test, you also know it. I know that you will not forget it. That Wilcoxon, Mann-Whitney, sign rank test, and these are the non-parametric. Yeah, of course, chi-square. How can we forget it? So today I'm not going to talk about the non-parametric test, but I'm going to talk about the parametric test, and most importantly is t-test. Somebody will say, what is t-test? So if somebody is asking to you what is t-test, you can say that t-test is comparison of means. When we compare mean from the population mean either, or we can compare the mean with other sample mean. So okay, now before going to the t-test or deeply into the t-test, I just wanted to explain you what is this parametric actually and why we call it parametric. Okay, now parametric test actually it satisfies some parameters or some assumptions, and these assumptions, basically two main assumptions are: one is that the data should follow the normal distribution curve. It should come under the normal distribution curve. And the second one, which I think is again important, that we should have some information about the parameter. Parameter means mean, population mean, as well as the variance, or if not possible variance, at least one we should have. So population mean, and which is called also mu. Let me explain this also, that the parameters, actually all notations which we are using for population is called parameter, and the notations which we use for the sample are called statistic. Not statistics, but statistic. So okay, that maybe is enough for the inferential statistics. We are going to do some coding for this also. So for doing coding, I am going to use this R Studio. You can use the simple R also. Let me start the R Studio. So here you can see the console. Okay, now I'm writing console only. I'm not writing any script and making everything is there. So for the t-test, the command is very easy, t.test. But we have to follow some there is syntax. Must have some arrangements or some material which we have to fit it. So not going too deep in this. I'm just going to write some values. Let's say I'm saving value in B. So the B is actually, we can say that there is a vector which have 12, 3, 45, 6, 23, 78 and 45, 9, 12, like this. Now let's say this is actually illness of something. Somebody is having this kind of illness, or no, illness is not good, so we can say that people may have these number. Somebody have these number. Now I just wanted to check that these number is actually, is there any significance difference, or is there any evidence that the mean of the university numbers, let's say the university number mean is actually say 25, is there any evidence that the mean level of the university average marks is greater than 28 or not? So 28 is a mean average of the university. I just wanted to check it is the marks which I have given here is greater than 28 or not, and I have to compare the mean. So what is the test? It's very easy. Here only one sample, which is B. The test is T dot test. Now the T dot B, and then we have to do it. So this B is actually, this is a vector which we are talking about. B, then okay, we have to see that are we checking actually alternative hypothesis. So the command is alternative. Yeah, you can see it here also. Alternative is equals to what we want to see. What we have said earlier, I have said that greater. Is it greater than 28 or not? So I am going to use this greater word. So greater. So yeah, and I am comparing this greaterness with the population mean. Population mean is called mu. So mu should equals to 28, which I have told you earlier. And then I can write it variance equals to false. So I am writing also variance equal is equals to false. Sorry, it should be in capital. And I am writing confidence interval also, which is called here in confidence level. Yeah, that and confidence equals to 0.95. Okay, let's see what is actually giving you. Yeah, I am getting some answer. Great. So the value of T is minus 0.2522, degree of freedom 8, which we can see that this is n minus 1 should be there. So there are 9 values, n minus 1 is equals to 8. The p value, which is actually important, 0.5964. What does this mean? We have to reject the null hypothesis. We have to accept the null hypothesis. The p value, if it is less than 0.05, then we reject the null hypothesis, and when it is more than 0.05, we accept the null hypothesis. And here we can say that it is 0.5, so we have to accept the null hypothesis. And null hypothesis saying that is there any difference? Null hypothesis was no, there is no difference, so we have to reject the alternative hypothesis. Okay, that's all. Or should I tell you something else? Let's see.